Right, so in this video we're going to have a look at how to convert numbers from positive to negative and negative to positive. Now, the concept that you will learn to do this is what we call two's complement, and it's a way to represent signed integers in binary form. And signed integers has been discussed in another video, but it's any value that is positive or negative and can be represented in binary. Now, what we have to know about this is that with there are two methods that we're going to sort of go through here. We're going to look at, first of all, how we take a binary number and work out what it is in its decimal form, and then we're going to do it the opposite way around, so take a decimal number and then convert it back to binary, and there's a little test for you to do at the end. So let's assume we want to convert the binary number 1, 0, 0, 111, 00 into decimal using two's complement. What we do first of all is, you notice we write out the binary number like we would do normally. But the one difference here is that we place a minus 128 on the end column. Now, the minus 128 is used for us to work in reverse, essentially, as to how the binary number will be sort of understood and read. Imagine like a mileage, like a mileometer on a car, odometer on a car. As you increase mileage going forwards, it goes from 1 to 2 to 3 and so on. If you were to go in reverse, it doesn't get to 0 and then starts working back in the opposite way. But actually, this is very similar to what this is actually like. Okay, so we're going to have a look at the next phase, and the next step is to so the next step is to add the values as we normally would, but bearing in mind we've got a minus 128. So what we do this time is we take the minus 128 and then we add 16 to it, add 8, add 4, and that gives us an answer of minus 100. So you follow that format every single time, and what you'll end up with is a situation where you can always accurately convert two's complement binary values from binary into decimal. Bearing in mind that when you do this, it's really very important that you remember that if it's in an exam question, if it refers to a signed value at the start, you're always looking for that 1 or 0. If it says it's unsigned, then you can just presume it's a positive. You can just presume it's a positive number. Okay, so now we're going to look at the second method, and that's to convert a decimal into binary using two's complement, and it is a slightly more confusing way of doing it. There's 3 steps involved in this, and if we take the number minus 102 first of all, what we're going to do with minus 102 is we are going to write out what the positive value for 102 is in binary. Now notice that we've got minus 128 here. Just for the time being, that just becomes 128, and we're going to place a 64 and a 32, a 4 and a 2 to give us the answer of 102. What we're then going to do is we're going to then start with the least significant bit, and the least significant bit in a binary number, which you will have seen in one of our other video tutorials, is the number on the furthest right hand side in binary, because that is the smallest binary number, and we're going to start there. And the first time that we reach a we're going to ignore any zeros, but the first time we reach a 1, every number thereafter is going to be switched around. So we're going to convert the zeros to the 1. So we can see in the number minus 102, there's nothing on the 1 here, but there is on the 2's column, there is a 1. So we're going to meet up to this point. What we then do is we are then going to swap the remaining bits around. So you can see that the 1 becomes a 0 under the 4 column. We can see that the 0 becomes a 1 under the 8 column, under the 16, 32, 64, and then we have the 1 at the front there on minus 128. So we've converted them around. So the final answer that we get for this is that we have a situation where we've now got 1 0 0 1 0 1 0 0 1 1 0 1 0, and there is a further step to go involved. Well, that is the final step actually. Yeah. So that's our final answer that we put down: 1 0 0 1 1 0 1 0, and there's our answer of 100 minus 102. So now there's a couple for you to practice and do here. So I'd like to have a go at converting the binary number 1001111 into its decimal form, and then I'd like to do the same for minus 97, but this time from decimal to decimal into binary. So pause the video now, have a go at them both, and then I'll explain the method to them. Okay, so following the steps that we have looked at previously, if we want to convert this number 1001111 into its decimal form, what we're going to do is we're going to place a minus value here. So we're going to have a minus 128, and we're going to add 16 to it, and we're going to add 8 to it, we're going to add 4 to it, and we're going to add 1 to it, which, if we just apply our maths, we're going to end up with minus 112. We're then going to have minus 104, 100. We're going to have 99 as our final answer. So the value is going to be minus 99. And just so I can make sure that I haven't made any absolute fundamental flaws there, we're just going to check that on the calculator, because sometimes minus values can be a little bit annoying to work with. So we're going to go plus 16, plus 8, plus 4, plus 1 gives us an answer of minus 99. And there we go. Okay, so to do it the opposite way round, what we're going to do first of all is we are going to place positive 97 into our answer here. So we're going to have a 0, a 1 and a 1 to give us 96, and then a load of zeros, and then we're going to have 1 on the end to give us 97. And then, a bit like what you saw in the earlier steps, what we now do is we're going to basically say this becomes a minus 128. And starting from the least significant bit, so the right-hand side, everything up to and including the first 1 remains the same. So it's going to be a 1 here, but then everything thereafter switches round. So we're going to have 1, 1, 1, 1. And then we're going to have 0, 0, 1. So minus 97 represented in binary form is, as you can see it, just here. And I hope you found that video useful.